Hello everyone, a very good morning to all. I hope you and your family is healthy and safe during this pandemic. Vedic mathematics is a gift given to this world by ancient sages of India, a system which is far more simple and enjoyable than modern mathematics. With this note, I, Rachana Krasta, Assistant Professor, Department of Mathematics, take this opportunity to welcome you all for the first webinar hosted by the Department of Mathematics, St. Joseph Engineering College on Vedic mathematics and its applications. To enhance our knowledge on Vedic mathematics, we have amongst us Professor Raghavendra Prasad, a firm believer in fruits of hard working. Professor Raghavendra is working as an assistant professor in the Department of Information Science and Engineering, RV College of Engineering, Bengaluru, for the past 15 years. He has received A+ grade in Vedic Mathematics course from Institute of Vedic Science, UK. He was the resource person for research and application of Vedic mathematics in digital systems held at IAVM, that is Institute of Advanced Vedic Mathematics, UK. He was the chief coordinator for 3rd International Vedic Mathematics Conference held at RV College of Engineering in association with IAVM, UK. He has presented 5 papers in the Vedic Mathematics International Conferences held at Kolkata, New Delhi, Bengaluru, Hyderabad during 2016, 17, 18 and 19 respectively. He has given invited talks on applications of Vedic mathematics in engineering at Dayananda Sagar Institute of Technology and Management, JSSATE, New Horizon College of Engineering, Samskrita Bharati, Aksharam, Bengaluru. Also, he was a resource person for a number of online webinars on digital applications of Vedic mathematics, which are now available on YouTube. He is a member of expert team of SAMVIT Research Foundation, Bengaluru, created the modules of Vedic mathematics for NCERT High School Maths as a part of Pride of India project and trained 35 teachers at first stage to implement for 140 schools in Karnataka. He was a shortlist candidate for Teacher Innovator 2016 MHRD Award Stage 2. He has completed machine learning course from Electronics and ICT Academy, IIT Kanpur, and shortlisted as star performer. Attended the 3rd IEEE IDACCS Symposium on Wireless System in Germany and presented a paper on NS3 simulation studies. He is SCSC chair for 2020 IEEE Bengaluru section. From the past 4 years, to acquire the updated knowledge of latest research works, he has attended 500 plus webinars from IEEE, DAD, ACM, CMG, etc. He is a reviewer for Learning with MOOC 7 2020 conference to be held from 30th September to 2nd October 2020, Antigua. He has earned 4 IEEE Continuing Education Unit Certificates, 75 IEEE Professional Development Art Certificates. He also has professional membership of ACM, Life Member ISTE, Life Member Indian Institute of World Culture, Life Member Institute for Advancement of Vedic Mathematics UK, IFERP Senior Professional Member. He is NCC C certificate holder and got first prize in singing from Chandana TV. Dear sir, we are happy and delighted to have you as the resource person for today.
Yeah.
On behalf of the entire SJEC family, I extend a hearty welcome to you, sir.
Thank you, ma'am.
The success of this webinar is definitely because of the participation of students and faculty members of various institutions. I welcome all the attendees for this webinar. A warm welcome to one and all. I now request Dr. Ramananda HS, HOD Mathematics, to speak a few words.
Good morning, one and all. Department of Mathematics, St. Joseph Engineering College has 10 teaching staff. All are having more than 7 years of teaching experience. The faculty members are actively involved in teaching and research. Department has a VTU recognized research center. 2 guides and 3 research scholars are working in the research center. We provide a strong foundation of mathematics to all branches of engineering students. We also handle essential subjects of MCA, MTech. Our faculty provides aptitude skills which is required for placement activity of the students. The department has MOUs with neighboring institutions, assisting PG students for their research projects. SIGMATS is the department association through which we conduct various activities for the students. Have a great day.
Thank you, sir. Participants, kindly note your mics are muted by default. So for any queries, please make use of chat box option. At the end of the session, a feedback link will be shared in the chat box. Feel free to give your opinion about the webinar. An e-certificate will be sent to you on submission of feedback form. Thank you. Now I request Professor Raghavendra Prasad to take over the session. Over to you, sir.
Yeah. Thank you, ma'am. Hope I'm audible.
Yes, you're audible.
My PPT is visible?
Yes, visible, sir.
Thank you very much, ma'am, for the nice introduction. And I thank Dr. Ramanand sir, who has given me an opportunity to share and also discuss with the students as well as faculty members what the work I have done related to Vedic mathematics. This is a contribution from India, so we should be proud enough so that this should be helpful for our education purpose as well as to do better in mathematics also. So thank you very much, and I'll start with the initial points. So whenever we look into what is called as Vedic mathematics, there are so many inputs are there. One who is going to listen to the word Vedic mathematics. Oh, once again another mathematics. This is one. And some of them what Vedic mathematics already we are having so much mathematics. There are mixed comments from the people who are going to listen to this Vedic mathematics. Let it be, because each one has its own way of thinking and also implementation of such things. So my presentation goes like this. So whenever we are going to think of something a different one, so we always as a researcher or something, he has something been done in terms of paper presentation or in the conference and all such things, we will look into that. So initially I will go through the outline of what are some basic papers which are presented in IEEE, SJEC and also Science Direct. And one of the professors from Hyderabad has implemented Vedic mathematics into microcontrollers. It is available in the electronics for you also. Next, about from where Vedic mathematics has originated, Bharati Krishna Tirtha ji, basics about we have to know about Bharati Krishna Tirtha ji and also the book which is available. And let us have a, so anything mathematics we have to think of. So it is abacus is available. There is another method, Trachtenberg speed mathematics, Japanese method, Vedic maths, and so many are available. Why should we have look into what is called as Vedic mathematics? We will discuss. Then we will have some problems we are going to work out, and also we will look into that how it is helpful for us. And it is not possible to cover in a span of 1.5 hours all the thought processes which are developed and also presented in Vedic mathematics. I'll take up some of the problems which may give you some basic idea about Vedic mathematics as well as some implementation in digital system also. So then how we can apply in digital system? Then in our institution, they have implemented one of the algorithms in Vedic mathematics by using method. In the microcontroller, the next level we can implement in the processor and also the microcontroller as a part of arithmetic logic unit. Then if time permits, we will have a look into something called as a Knight's problem. And also why Sanskrit is very important, and we are in the era of machine learning and also artificial intelligence, and automation is taking place. How mathematics is very helpful for that, how pattern recognition is very helpful. Although mathematics is an abstract subject, how this abstract subject, it is very helpful for imagination as well as whenever we want to have a check, yes, whether it is applicable or not, to check the bounds of these and what are the shortcut methods and all such things, definitely it plays a very important role. Then I'm going to display some of the resources of learning. One who is interested, who want to look into where all Vedic mathematics is available, I'm going to give a brief of it, as well as from 2016 onwards, Vedic Mathematics International Conference is being conducted in India at different places. This year also we have, preferably if we are going to come out of this COVID situation, we'll be having Vedic Mathematics International Conference to be held in Kerala during 28th to 30th of December. We have time to present some papers also. And then the conclusion. So this is overall picture of what I'm going to discuss for another 1.5 hours of time. If you have any questions also, you can in between, you can interrupt, type some messages, and can have a look in. So I'll start from digital implementation, what already people have done. Then we get into the core of Vedic mathematics. Then again, what is the implementation? I go like this here. Fine. So when we just browse in the international, this is the recent papers which are there, which I have collected in IEEE, Springer, and also Science Direct. People have presented, only have taken some of them. There are many papers are available. Modified binary multiplier circuit based on Vedic mathematics. Use of Vedic mathematics, speed up basic mathematical operations in Android-based calculator. Novel approach for multiplier design using ancient Vedic mathematics. Research on IEEE 754 single precision floating point multipliers designed using Urdhva Sutra of Vedic mathematics. Efficient Gabor filter using Vedic mathematics for high-speed convolution in skin cancer detection. Then neuronal logic gates realization using Vedic mathematics. So I have taken papers from different different applications, but we have a keyword what is called as Vedic mathematics in this. So that means to say, around the world, people are working on using Vedic mathematics, and they have published some papers also which are accepted in very good journals like IEEE, Springer, and also Science Direct. This gives a small insight into some work is going on, and also some work is going on related to the applications of Vedic mathematics in digital systems. Fine. Now, directly coming to applications, this is available. You can just Google Vedic mathematics applied to microcontrollers. You are going to get this is presented in 2015 by Dr. Suresh Babu, who is the current HOD in the Department of Electrical Engineering in Chaitanya Bhagat Institute, Hyderabad, in association with P. Chow Reddy, who is Managing Director in Intel Technologies here. So they are able to apply Vedic mathematical algorithm, and they have found that whatever the application they have run, it is running at a time 15 times faster than the original speed. That means to say there is a reduction in the time taken to compute. One example they have already demonstrated, and some more examples also they have given. Some directly have taken the conclusions. Although this is related to mathematics, again mathematics relates to computation. One such thing here. So he has drawn the conclusion that it is applicable in mobile applications, transformer winding machines, as well as aerofoil controllers and all. So they have concluded that Vedic mathematics improves the speed here. Already we are working, our processes are very, very fast. We are using multi-core process and all these we have learned. But still, can we utilize these methods to see to that our arithmetic logic unit still performs better is also another thought process also we can think in terms of this. This is some already done work. Okay. Now coming to Vedic mathematics, whenever we just Google, we are able to find Vedic mathematics by Sri Bharati Krishna Tirthaji Maharaj. So he was born in 1884 and he was educated in a pious family, and he received top ranks in school. And he sat for MA exams of American College of Sciences in New York in Sanskrit, philosophy, English, mathematics, history, and science. So he was able to complete all 7 post graduation in a span of 2 years. So this is his related to Bharati Krishna Tirthaji. His earlier name was Venkataramana. Gopal Gokhale in 1905 for the national education movement and the South African Indian problems. However, his inclination towards Indian culture led him to study of ancient Indian scripture, Adhyatma Vidya. Then he wrote a number of treatises and books on religion, science, mathematics, world peace, and social issues. So out of all these, he was able to, so since we are mathematics students and also faculty members, so we are very much interested what is there in Vedic mathematics. So just to Google, you are able to get the PDF of this book also. So this book is, he wrote 16 volumes of books and he gave it to his disciples and also students, somebody mentioned. And again, all these books were lost. So why Vedic mathematics? It is given in the preface that we have studied in our schools 4 Vedas, Rig Veda, Yajur Veda, Samaveda, and Atharvana Vedas. These are the Vedas which are there. And also in Atharvana Veda, there is a part what is called as a Sthapatya Veda. It is called as maths of engineering, construction, and so many other things are explained. So he studied that part of Sthapatya Veda, and he formulated some 16 sutras. So these 16 sutras are applicable. So whenever we are going to think in terms of such patterns, we are able to apply that, and also we are able to solve the problem faster is mentioned here. Faster in the sense what? Whenever we think of solving problems of mathematics, we always take a paper and pen. We are going to start with that. Yes, that's always a good practice. But is it possible when you are able to see the problem and you are going to mentally calculate and you are able to say the answer here? This is what a trial we can also take it up here. So now, and since these 16 volumes of books were lost, again he wrote, and also one of his students available is mathematics is available. With that, most of them are arithmetic and also algebraic expressions and computations are given, as well as some basics related to the calculus is also given here, and something related to geometry is also given in this particular book which is available. Now, think of computation. So we think of mathematics. So we see our the parents will be sending the children for the any of these courses and all that they can learn. So these are the available some of the computations. There is one more method what is called as the Trachtenberg speed mathematics is available. And when you see down here, there is what is called as the Japanese method of mathematics is also available. And one more in the left hand side, left bottom corner. So there is a so these are the methods that fine. As a mathematics student, we need to look into these things so that is there any good that I can solve the problem quicker, because always mathematics when we are going to solve, one is approach towards the problem solving, as well as how fast I can solve the problem and how fast I can digest, and also I can simplify this so that anybody I can teach also it should be possible for me. This is what we are going to look into. So since we are into Vedic mathematics, now let us have a small look into this here. You see peacock, when you see deeply observe, so we see some patterns also. Similarly, when you see down there, there are so many small patterns are there. Whenever anybody who is going to take examination of a competitive examination for banking and all such things, you can see the pattern matching is a very, very important thing. In the right hand side, you can see so many patterns. There is triangle, rectangle, square, pentagon, and all these are available. Then some circles are there, some colors are also given, and the circle is rotated, and some number rotation is also there, and numbers are there like 2, 4, 6, 12 dash dash dash. This is an arithmetic sequence we have got. Similarly, next one is 2, 4, 8, 16, 32, 64, 128 dash dash dash. So it is a geometric sequence we are going to call it here. That means to say, we can see in this world there are so many patterns are also available. The pattern here, so we have got a fingerprint. We see the leaves, they have got patterns, and similarly you can messages, so many things we are going to observe, people will be sending. So multiplication with 1 into 8, 11 into 8, dash 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 dash. So our focus is when we think of this, so we can think of, so that means to say there is some patterns are available in the world, and what is the pattern and our thinking is a very, very important. So what are patterns? So patterns are observations organized into meaningful categories by the observer. So we have seen so many patterns are there. Yeah, this is leaf. This is we are going to have a fingerprint, and if you go back here, so we are able to see a planar diagrams which are available also. So that means, so whenever a student or maybe yourself as a teacher or as a student, we seek patterns in the world around us, then we see the order instead of chaos. There is an order is there. When you see, go back to this here, there is an order, planar diagram. Yes, there is an order in arithmetic progression. There is an order in a geometric sequence is there. So there is some order in terms of this is leaves, they are arranged like this. So it is a pattern we can generalize like this. So when students seek patterns in the world around them, they see order instead of chaos, which builds confidence in their understanding and how the world works and gives them a feeling of control. Because we know our brain, it recognizes patterns faster than, so we are very good at pattern recognition than logical thinking. It is already stated there. Pattern, identifying a pattern and also utilizing the pattern to solve some problems is a very, very important thing that the brain is going to work with. Now let us have a small look into this here. I have taken in the column and also the row all the 2-digit numbers which are ending with 5 here. Okay, I am going to put it in Excel. Anyhow, the computation now it is shifted to all the digital system, maybe a calculator or a computer. So let me put into that, and I am going to have a product of all these numbers, each of these number with all the numbers here. Now let us see. 375, 525, 675. When you keenly observe, we can see something here. Observe this. So you can see, you can subtract like 375 minus 250 and 525 minus 370, or you can see the columns are that, and so many observations can also be made. But one such a pattern, observe each of the products what you have got. See, 15 into 15 I have got 225, 15 into 25 I have got 375, 15 into 35 I have got 525, 45 I have got 675. You see alternately 225, 375, 525, 675. We observe that each of what they are ending either in 25 or ending with 75. So that means there is some pattern is available here. I know very well that I have observed that. So when you take the 2-digit numbers which are ending with 5, I am going to multiply with this. Definitely the answer should be, that is the 10th place and also unit place. When you take, it will either end with 25 or it will end with 75. So that means, so it is fixed. Only some pattern I can easily find out. Can we find out the answer? We have the problem. So that means we are getting into what is called as pattern. Since we are going to study something in Vedic mathematics, I have given one such pattern in leaves and all such things. One such pattern which is available in the numbers which are ending with 5 with our 2-digit numbers. Okay. Now coming to why I gave this basic the Whole of Vedic mathematics thinking, it is based on the patterns. We need to identify pattern and apply a suitable sutra or the formula for this so that we are able to make it. So once we are going to practice with pen and paper, then once we practice, it is possible that by looking at the problem, we can solve the problem within a span of some 5 seconds or max. Definitely, people are looking for Vedic maths applications in the competitive examination, as well as trying out when it is possible to solve the problem through our brain. Why not a digital brain also? We can't such things in digital systems also. It is another question. So to learn Vedic, it is not necessary we should know Sanskrit. Already these translations are available in both Kannada and also English. So we can definitely implement. As a mathematics student, we need to identify what is a pattern, and also while solving, how do you apply this formula or sutra is a very, very important one. Just to say one or two, one is there by one more than the previous one or before. Next is Nikhilam Navataha Charamam Dashataha. All from 9 and last from 10. And crosswise. Paravartya Yojayet. Transpose and apply, and so on. We are going to come across like this. So there are 16 such. Not necessary we need to by heart all these things. And when you are going to practice, have a look into that, then definitely we can remember so many things also. Fine. Similarly, there are some sub sutras are there which are very, very helpful. We say corollary and all. Proportionately. And so many other things are there. So not necessary. Don't be worried about Sanskrit or should I know all meanings. No need to be. We being mathematics students, we can definitely, when solving the problem, we can learn this also. So we what are patterns? How our brain is going to identify some patterns, and how Vedic mathematics is very helpful in identifying the patterns. So we initially we go through what is called as what is called as vertically and crosswise. Now let us 2-digit number, let us say 20 and 22, something like that. So we know the method, that's okay, not a problem, and we can easily solve the problem. But this vertically crosswise is very, very helpful in so many places also in Vedic mathematics. So you need not have to by heart anything, only just you can easily identify this. So I have put it as dots to make it generalized. CD and all these things, it becomes very, very difficult. Instead, I will take it as dots. Now, speciality in this is, so whenever we multiply in general way, we are going to start from right hand side. Let us say 22 into 23. I will multiply 3 into 2, again 3 into 2, again, then 1 left, then 2 into 2, 2 into multiply. So in Vedic mathematics, it is possible. I can either start from left hand side or from right hand side. So let us follow the right hand side itself. So when I look from right hand side, you see the step 1. I am focusing on like 2-digit multiplication. So 2 dots are there and below 2 dots are there. When you look from the right hand side, when you come from you can see the column there. So you see those two have to be multiplied, which is called as vertically. Then move ahead. Move ahead means we will see 4 dots are there. When 4 dots comes to picture, I'll take what is called as crosswise. Next, once all the, if I have gone to the last column, then leave 1 by 1 column. So I'm going to get the last column, which is again vertically. Similarly, when you come across 3 digits, let us say, I'll come from right hand side. First, I'm going to come across 2 dots vertically. 1 more column I'm going to take, I'll take crosswise. Three columns I am going to have it here. Then take the first column and last column as crosswise and the middle one as vertically. Once we have achieved the last column, when we have touched the last column, leave 1 by 1 the columns. So again, we are left out with the crosswise. Here. It goes on like that. No need to worry. No need to remember so many other things. This is good enough. So we are able to recognize the pattern. Let me take up one example here. So 21 into 23, when I multiply, it is 483. How should we solve the problem here? Now we'll start either from left hand side or right hand side. I can start. If I start from left hand side, first I will come across 2 and 2 vertically. 2 2s are 4. Next is I will add one more column here, that is 1 and 3. So therefore we have got, I will have crosswise 2 into 3 is 6 and 2 into 1 is 2. 6 plus 2, then I am going to write the answer is 8. Once this is either I am going to go, I am left with only 1 and 3. 3 ones are 3, I can easily multiply. Yes, this is not a difficult task. I can easily solve it. Just to have a understanding so that it is applicable in so many problems also. So when you look into this, now can you try to solve the problem? So I'll start from left hand side here. I will see the column 2 1. So that 2 1 2. Then one more column I'm going to take. You take crosswise. 1 1s are 1, 4 2s are 8, 8 plus 1 is 9. Since I have reached the last column, leave 1 by 1 column. Left out is 4 and 1. So therefore 4 1s are 4. So answer will be 290. So we have calculated mentally the answer. Again, if you want to write out, you start from left hand side. See here, you will see the first column which is 1 and 2 vertically. 2 1s are 2. Write down or just remember this 2. Then one more column. So 1 1s are 1, 4 2s are 9. Then again last column 4 1s are 4. The answer becomes 294. Now already you have practiced mentally solving this problem using vertical. Taking one more example. Just focus on the left hand side, that is step 1, step 2, step 3, step 4, step 5 are given. So hand side, initially vertically 2 dots are there, take those 2. Again one more 2 columns when you get crosswise, when you get 3 columns, so first column and last column crosswise and the middle column vertically. Since we have reached the dead end, leave 1 by 1 column. So again only the last 2 columns are left out crosswise and also last column which is vertical. When you take an example of 7 8 9 and 2 6 3, so I start from here. First one 9 3 is 27. So whatever the carry is there, that will be written in the second row in the answer here. 27, it goes to column 8 into 3 and 9, I'll get 78. Adding those 2. Again one more column when you take 7 into 3, 2 into 6, which results to 87 here. I'll take that 87. Then leave one column, that is 9 and 3. So we have got 7 into 6 and 2 into 8. So 42, 58. And the last column 14. Then add these two, 207507. Yeah, you may find initially it may be cumbersome and all such things. Just to have a look in how this vertically crosswise, I have taken an example. This is how we are going to solve vertically and crosswise here, but we can simplify further also. Fine. One more example also you can have it. So usually whenever you attend any of the webinars related to Vedic mathematics or any of the, so they will take a arithmetic part of it. Now, what is called as the linear equations in one variable and polynomials, multiplication, division, I'll go from that side. Then we get into arithmetic part. Then what is the implementation in digital systems? Let's see. It's very simple. 8th standard mathematics. Solve the linear equation 2x minus 3 is equal to x plus 2. Either I can subtract x on the both the sides and I'm going to solve, or any of the methods, like you can shift that x part to the left hand side and the constant to the right hand side. That's fine. Now there is a method what is called as paravartya yoje, which is called as transpose and adjust. Adjust, if you solve the equation ax plus b is equal to cx plus d, we end up with equal to d divided by a minus c. Then we can apply it. Yes, there is a chance. Let me see. You can see the right hand side of it. Solve 2x minus 3 is equal to x plus 2. Compare it with ax plus b is equal to cx plus d. Now a is equal to 2, b is equal to minus 3. To substitute in the given, that's okay. D minus b divided by a minus c. So 2 minus of a minus c, that is equal to minus 1. So which is 2 plus 3 divided by 1, which is equal to 5. What is the great thing in this? Now, by looking at this, can we directly try to solve the problem? Here is another thing. One already got in the left hand side. In the right hand side, I will try to solve the question mentally without writing anything. So when we see x is equal to d minus b divided by a minus c, when this is ax plus b divided by a is equal to cx plus d. Now in this given equation, when you start from the right hand side, see here you have got 2x minus 3 is equal to x plus 2. The constant on the right hand side is 2. My constant is 3. See here, my numerator is d minus b. Now I'll forget, I need not have to remember the formula also. I'll see a pattern. It is in the form of ax plus b is equal to cx plus d. It's very simple. I will start from right hand side. To get the numerator of my answer, what I will do, constant in the right hand side minus constant in the left hand side. 2, it is equal to 2 plus 5 divided by the coefficient of x in the left hand side, coefficient of x in the right hand side, which is 2 minus 1, which is equal to 1. So hence my answer is equal to 5. So we started from solving of 8th standard mathematics. Then this is x is equal to divided by minus c. Now you need not have to remember the formula of d minus b divided by minus c. If you observe that it is in the form of ax plus b is equal to cx plus d, it's very simple. On the right hand side, once you have to, it should be in the form of ax plus b is equal to cx plus d. Constant in the right hand side minus constant in the left hand side divided by the coefficient of x in the left hand side minus coefficient of y. Next one here. Can you try out this? I am not going to write anything. It is in the form of ax plus b divided by cx plus d. Definitely try applying this and get the answer. Constant in the right hand side minus constant in the right hand. 8 equal to 5 divided by 5 minus 3. Answer is 5 by 2. This is a pattern ax plus b is equal to c. Paravartya by transpose and adjust we have derived it, but we have got one more step ahead. We recognize the pattern, we are able to stop. I'll go ahead with the next one. 4z plus 3 is equal to 6 plus 2z. First we need to see to that it should be in the form of a is equal to cx plus d. I'll bring it into that form. Can you try to apply this? I'll pause. Able to do it. Comes, I'll start from right hand side. Right hand side minus in the left hand side. 6 minus 3 is the numerator, and coefficient of z in the left hand side minus coefficient of z in the right hand side. 4 minus 2, which is equal to 2. So my answer will be equal to 3 by 2. We are able to get the answer. Nice. Suma madam has given the answer. Very nice. Hope you got it. Okay. So this is 8th standard mathematics. Oh, now there is one more problem is there. I have got x plus 1 divided by 2x plus 3 is equal to 3 by 8. So what I will do, I will cross multiply and dash dash dash. I am going to do to solve the problem. Fine. Is there a pattern for this? Let me check. This is of the form ax plus b divided by cx plus d is equal. When you solve for x, it becomes x is equal to minus of bq minus dp divided by aq minus p, which is a formula difficult. This. Let me type. Ax plus b divided by cx plus d is equal to p by q is there. What I will do, I will observe all the numerators, left hand side and as well as the right side. You take out the coefficients as well as the constants. The coefficient of x in this is a, I'll write a, then the constant b, then the constant on the right hand side is p. You can see a, b, p. Similarly, you see the denominator cx plus d, and here in the denominator of the right hand side is q. I'll write c, d, q. Now let us see how do we work out. I am saying we get x is equal to minus of bq minus dp divided by aq minus c. We wrote down a, b, c, d, q. Hope you understood. I'll start from the middle column, that is b minus q. Start from the top to b minus bq minus dp. This I got. For the time being, no, don't focus on minus sign. So that is a numerator part without minus sign. Again, so you can just check the other part. So start from the last column to the left column to the right column there. So A cube minus CP, you are able to get. So one is either I can take the values of C, P, Q and substitute in the given formula. X is equal to minus of B Q minus DP divided by A Q minus CP. I can substitute. Yes, there is no harm, and yeah, we know this already. So let us have a look into this. All the problem here. X plus 1 divided by 2x plus 3 is equal to 3 divided. So comparing with ax plus b divided by cx plus d is equal to 3 by 2, I get a is equal to 1, b is equal to 1, c is equal to 2, d is equal to 3, p numerator in the right hand side, that is 3, and denominator is 8. Write it in this form. This is more than sufficient. I can easily solve the problem. What I should do? I am going to substitute here, that is minus of bq minus dp divided by aq minus cp. Remember, then substitute and solve the problem. That's fine. Again, that's a routine process there. I want to skip this. I want to do, I want to solve the problem directly. When you observe bq minus dp divided by aq minus cp, we have already created. So to get the numerator without that minus sign, what I will do, take the middle column and also the last column, bq minus dp. I am going to do it here. If you remember this pattern, that is good enough. bq minus dp, if I the sign also, yes, to find out the answer, initially we focus like this, bq minus dp, and then move to the last column, that is the first column, also the last column, aq minus cp we are going to take. To directly tell the answer, what I will do, I will initially calculate the numerator without the sign. So what I will do, so I will take the first middle, also the last column, that is 1, 3 and 3, 8. So 1 8s are 8, minus 3 3s are 9. 8 minus 9 is minus 1 in the numerator currently. And take the, I want to find out the denominator. 1 2 and 3 8 is there. 1 8s are 8, minus 3 2s are 6. So 2 in the denominator. I have got minus 1 by 2 is the answer. But I have to put a minus sign with that. So answer is minus. So observing this pattern, we can see that without solving, like substituting for A, B, C, D, by just looking at this pattern, we are able to solve the problem. By transpose and adjust, we have already derived. Just one more step ahead. Okay, what we can do, bq minus dp divided by aq minus cp, if you are able to do, ratio you are going to get here, multiply with minus sign, we are able to get the answer here. Now once again, let us try out. So 1 3 x plus 1 divided by 2x plus 3 is equal to 3 by 8. 1 1 3 2 3 8. So I know very well that this is in the form ax plus b divided by cx plus d is equal to p by q. Simply write down these values. Then you can solve it. Other way also, the other problem also, this one more, when it is in the standard form ax plus b divided by cx divided by p by q. So 1 8s are 8, minus 3 3s are 9, 8 minus 1, minus 2 3s are 6, 8 minus 6 is equal to 2. I'll get minus 1 by 2, minus of that I'm going to get this. Similarly, let us go ahead. Can you try out this? 4x plus 8 divided by 5x plus 8 is equal to 5 by 6. Just check whether this is in the form ax plus b divided by cx plus d is equal to p by q. A, B, P, C, D, Q. So in our case, it is 4, 8, 5 in the first row, and in the second row, it is 5, 8, 6. Once you are done, yeah, good, nice man. So what we get, you just observe. So we are able to solve. So very simple. So 8 6 are 48. minus 8 5s are. So you have to write down this 485 586 48 minus 40, which is 8, and 6 4s are 24 minus 25, which is minus 1, and put a minus sign with that, the answer becomes equal. Fine. Hope some basic things we are learning here. That's fine. Hope this method is clear. I'll go to the next level. We will go to the factorization. X squared plus 5x plus 6. So we have, we can split the middle term. We find the sum and also the product, and we are going to solve the problem and factorize. That's, we are already into that. Fine. What is a method which is available in Vedic mathematics? Again, this is also not so different, but when we practice directly, we are able to tell the answer. It is called as Anurupena, what is called as proportionately, and what is called as Adhyamadhyena and Antyamanthena. That means first by first and last by last. This is the one. So it is not difficult to remember first by first and last. How do we solve the problem? We go to a simplistic, which already we know, x plus 6, when you are going to factorize, it is x plus 2 into x plus 3. Now let us, don't read whatever is given there. You can easily get the insight into this here. By observing this, the coefficient of x squared is 1 and the constant is 6. So the product will be equal to 6 and sum is equal to 5. We go for the splitting the middle term. Sum is 5 and product is equal to 6. The possibility is only 2, 3. That is 2 3s are 6 and 2 plus 3 is equal to 5. So we split the middle term as, so I will now use annotate and try. Yes, I'll to write. So I can write it as x squared plus, I'm going to write this plus 2x then plus 3x. Either you can write 2x plus x, 3x, and then plus available here. Yes. So it is possible. We have split it like this. So what we do, take the first two terms, take x common factor, we are left with x plus 2. Take the next two terms, that is 3x plus 6, take a 3 out, and we are left with x plus 2, take x plus 2 common and again x plus 3. So therefore the factorization is x plus 2 into x plus 3. Now how in this method we are going to do? Now observe these four terms, x squared plus 2 6. See, x squared, that is equal to 1. What is the ratio of coefficient of x squared to the constant in the first, to the coefficient of x in the is to 2, and coefficient of x in the second, in the third term to the constant, it is 3:6, which is equal to 1:2. So we need to identify this common ratio. Once this common ratio is available, multiply with x and that constant, we can directly get the first factor equal to x plus 2. I'll repeat. You take in the given expression, it's a quadratic polynomial, we have split it into two middle term, x squared plus 2x plus 3x 6. Take the constant, that is the coefficient of squared, and also the coefficient of x in the first term in the middle, splitting of the middle term. The ratio of these two is 1:2, and we have 3x plus 6. The ratio of this coefficient, that is 3:6, is again it becomes equal to 1:2. Once these two ratios are matching, we are done with the first factor, that is whatever the coefficient of x squared, that is we got the ratio which is equal to 1:2. We have got. You can directly write one of the factors is x plus 2, we are able to write. Okay. Next, do this. Once we are able to do this, so what we do here? So we have, okay, already we have got x plus 2 is one of the factors. Now we have seen the form of what is called as by first and last by last. So what we are going to do, we already got x squared plus 5x plus 6, x plus 2 is one of the factors. Then divide each of, what is the first means, take this x squared, divide by x, and take this constant, divide by this 2. Yeah, so we get x squared by x is equal to x equal to 3. So the other factor becomes equal to x plus 3. I am taking a simple example. Later we will look into so many other problems also. So I will take, suppose instead of writing this as, if I am going to take it here, so instead of writing this as x squared initially plus 2x, now I'll write it as x squared plus 3x plus 3 plus 2x 6, if I am going to write 2x plus, we are going to get. Now observe the coefficient of x squared and also what is the coefficient of x in the first term. It is 1:3. Now take the next term and also this here, that is 2x plus 6. So this also it is 2:6 is, it results to what is called as, the ratio is 1:3. I am going to get it here. So when I get this ratio as 1:3, I can easily come to know that I have already got one of the factors which is equal to x plus 3 by this ratio. It's called first by first and last. Divide the first term by x, what we have got from the factor, and the last by last. I am going to get it here. So therefore, x squared by x is equal to, I have got x, and 6 by 6 I am going to get it as 6 by 3. I am going to get it x plus 2. So hence my what is called as the factors is x plus 2 x plus 3. Yeah, initially it may look slightly cumbersome, or maybe slightly you have got an idea with the next type of problem. Now let me check this. Now just by observing, see when you look into this, yeah, we have minus 4z minus 12. Okay, so directly I want to write one factor here. So what I will do, sum and also what is the product. The sum is equal to minus 4 and product is equal to minus 12. So this here. Okay, so when you check this here, so it is possible, one is 6 and 2, since it is minus sign is there, I have to write it as minus 6 and minus 2, minus 6 and plus 2. So I am going to split this as z square. This directly we when we are now we are learning the process here, Vedic mathematics. So we have already adopted our methodology. This is another way we can try out and also we can look into this. So I am going to write it as z squared minus 6z plus 2z plus 2z, and then I am going to write it as. If you are able to write this, it's good enough. You can easily solve the problem. Or if you are able to practice mentally in the mind, then also we can try it. Now see what are the coefficient of z squared and also the first term. I have got 1 and minus 6. This is the ratio. And you see 2 and minus 12. So which comes to the ratio itself is 1:-6. Hence z minus 6 is my one factor. Then last divide z squared and minus divided by this minus 6. So I'll get z plus 2. Hence I can directly write it as z squared minus 4z minus 12 is z minus 6 into z plus 2. So let us move ahead here. One more example and we can go with the next one. Now observe plus 5z minus 3. Sorry, 2x squared plus 5x minus 3. So my product will be, that is 2 into 3, which is equal to minus 6. Okay, and the sum is equal to plus 5. So the possibility is 6, and I am going to get, so 2 into minus 3. Okay, I am going to get it as, so minus 6, therefore 6 and minus 1 are the product. So what I will do, 2x squared plus 6x minus x minus 3. You observe 2 is 6, and also from the right hand side part, that is equal to minus x, that is I'll just write down. So this is 2x squared plus 6x. Minus, and we have got minus 3. Observe these things here. I have got 2 and 6 equal to 2 is to 6, and minus 1 and minus 3, I have got 1 is to 3. Finally, I am going to end up with the ratio what is called as 1 is to 3. So hence, one of the factors I am going to get it is, so therefore I am going to get it as x plus 3 is one of the factors. If I am able to identify one factor, you can easily write first by first and the last. So 2x squared by x, I am going to get it as 2x, and minus 3 divided by 3, I am going to get minus 1. So directly I am able to write the factorization of this is x plus 3 into 2x minus 1. Like this, we can further go ahead also. Okay, so splitting the middle term becomes a very, very important thing here, and identifying the ratio, you can easily do it here, which this method we call it as got what is called as so I'll go back to this scene. Proportionately divided. So we saw the ratio. Then what we did, first by first and last by last, we are able to, and we get of x squared plus 5 is x plus 2 and x plus 3, and z squared minus 4z minus 12 as z minus 6. Once I get z minus 6, or the other term also z plus 2 also we are able to get, we can easily get the next term also. Fine. So this is going into factorization here. Now let us go to the, so when you go to HCF again, we need to factorize this. I'm going to factorize x squared plus 7x plus 6 as x plus 6 into x plus 1, x squared minus 5x minus 6 as x minus 6 into x plus 1. Common is x plus 1, that's no great issue. Now when you take a cubic polynomial, I have got x cube minus 3x 4x plus 12, and x cube minus x plus 16x minus 12, and 6x to the power of 4 minus 11x cube plus 16x squared minus 22x plus 8, 6x to the power of 4 minus 11x cube minus 8x squared minus 22x plus 8. Another one example I would. So we have learned a method of factorizing, then find out. There was a question. There was. Sir, can you see the chat window? One question was there.
Hello.
Yeah.
Sir, it's better to answer the questions at the end, sir. You finish up your slides. Yeah.
Okay. Is it going?
Okay, yeah. Please.
First, let us say you please try to understand. Sir, PPT respond.
Yes, sir. It's visible. Go ahead.
Yeah. Yes, sir. So now get into this cubic and also the quadratic polynomial. Now there is no other go for this. We have to factorize and also find the commonalities of this. Now let us check. Is there any such possibility in view? There is what is called as Sankalana Vivakalanabhyam. That is what is called as and by subtraction. That is, it is called as Lopana Sthapanabhyam. In the sense, by alternate elimination, we want to eliminate the higher degree terms as well as the constants and find out what is the common factor. It's very simple. We go like this. Already I have seen, we have taken this one. For quadratic, it's not a problem. Again, cubic, we are going to find out is equal to 1 to plus 1 minus 1 plus 2 minus 2 plus 3 minus 3 try out and divide that by that polynomial and then go ahead. Is there any way we can try to find out this? Is what we do in this case, please observe, by Sankalana Vyavakalanabhyam means given the two quadratic polynomials x6 and x squared minus 5x minus 6, I'll subtract one from the other. X squared plus 7x plus 6 and x squared minus 5x minus 6, subtract. So I'll get 12x and plus 12. Then add x squared minus 5x minus 6 and x squared plus 7x plus 6. I'll get x squared plus 2x. What you do, you take out the common in the first term. That is 12x plus 2, I'm going to take out, remove that common. Again 2x squared plus 2x is there. Whatever the common is, you just remove it. In that, we are left with this x plus 2, this x plus 1 and also this x plus 1. And you observe here also, my x plus 1 will be a, what is called as a common, highest common factor. This we already factorized and we did it. And we are able to remove. So that remove this part, as well as I'm going to remove this part. The leftward part, which is common on both the sides, will be definitely the my HCF. I am going to get it here. Another problem. Let us. I am going to get to a cubic polynomial. So when you look into the cubic polynomial, it becomes a procedure here. Already is given here. You see x cube minus 3x squared minus 4x plus 12. Once you go on factorizing and all these things, you will get minus 2x minus 3, x cube minus 10x squared plus 16x minus 12, x minus 2 whole squared into x minus 3. Then you identify what is common. Is there any other shorter way to solve the problem here? The subtraction and addition. I have got x cube minus 3x squared minus 4x plus 12 minus 7x squared plus 16x minus 12. Then subtract. So I get 4x squared minus 20x plus 24 and add here. I'll get 2x cube minus 10x squared plus 12x. We see common is, that is 4 is common in all the terms I am going to take out. And here in this, I have got 2x is common, I am going to remove this. So we have the left out part. So with a span of 5 to 10 seconds, we are able to solve this, solve the problem. X squared minus 5x plus 6 is the HCF of these two cubic polynomials. One more example I'll take for a quadratic polynomial. We see, okay, one second, please. Just a moment, please. Yeah. So let us take up another example. We have seen this one, and again I had another quadratic. I'll just show you there itself. Quadratic was there. Okay, fine. Like this, what you can do when we go ahead, when you go for the biquadratic, again it takes cumbersome. It's a very lengthy procedure to find out the highest common factor by this and solve the problem here. So very simple, what we can do, subtract and add, then take out the common factors in each of them and remove it. We are left with some common factors which are related to the each of the terms, and left out will be my what is called as the highest common factor. This sounds identify without going for many steps, we are able to solve the problem here. Okay. So there are so many other problems are also there. This is just insight into dealing with polynomials. Now let us come to problems related to arithmetic come, so that what we can do here. We can share the PPT and shared. No need to worry. Please focus. No, not a problem. Now let us see. We have some problems also related to another polynomial and so many other problems. This is just a small insight into starting from solving a problem of ax plus b is equal to cx plus d and x plus b divided by cx plus d is equal to p by q, then vertically and crosswise, and how do we find out HCF, so that it gives a small insight. Yes, can we try out in this way so that I can find out the solution faster, or you can also try out in a way such that it should be possible for you to verify the answer also. That should be good. Now these are some different patterns in mathematics, in multiplication and all such things. Initially, let me try out this. Okay, we try with the squaring of numbers ending with 5. I'm going to take it here. Now it's very simple. So whenever the number is squaring ending with 5, you use the method what is called as ekadikena purvena, that is one more than the previous one. What is that? Now squaring of numbers ending with 5 is a pattern here: 35 squared, 25 squared, 45 squared, 65 squared, 85 squared, 110 squared, 115 squared, and we can straight away calculate the answer also. You do it here. So what we do, we are currently focusing on what is called as 35 squared. I know very well that this is a pattern where I am going to find out the square of number ending with 5. What I will do, I know very well that the number behind this 5 you identify, that this one. Ekadhika means one more than that. One more than this 3 is 4. I'll simply put the answer, that is 3 into the next number, which is equal to 4. 3 4s I'll write, that is I'm going to get 12 is this part, and this 5 squared I'll write it as answer is 25. Therefore I'm going to get 1225 is my answer here. So once you know this, it will be very easy. How do you find out 85 squared is also very simple here. Since the number is ending with 5, the number behind 5 is 8. You simply have to multiply 8 9s are. So you need not have to worry about what is the remaining part. So answer will be, I'm going to get 7225 will be my square of that number. Can you try out this? We already know, but still you try out a method what we have already described. I want to find out 25 squared. The number behind 5 is 2. 2 3s are 6. Answer will be 625. I'm going to get it. Similarly, if you want to try out, let us say I want to find out 75 squared. So now you can type the answer, and also you can in the chat window. I want to find out 75 squared. I want to find out 65 squared. I want to find out 95 squared. Yeah, 75 squared, 7 into 8, 5625. 6. Next is 6 into next number, 4225. Next 9 into 10, 9025. Very nice, you are getting the answers like this. This is one such pattern what we have got. Whenever we are going to find out, very nice, we are getting the answers there. So you know this procedure, like whenever the numbers I want to find out squares of numbers ending with 5, I can simply take the number behind 5, multiply that with one more than that, and put simply the number 25 with that. You are able to get the answer. That's good. Yeah, and most of the things are already many times you are going to have an exposure for this. Now let us have a look into other type of problems. We are on squares. Let me focus on this is done. Let me focus on this part here. I want to find out 98 squared, 13 squared, 104 squared, dash. There is a pattern here we can see. In Vedic mathematics, we take the powers of 10 as the base here. If I to the power of 1, I'll get 10 is the base. Then near to base 10. 10 to the power of 2, that is 10 squared is 100 is the base. 10 cube, 1000 is the base. Whenever the numbers are nearer to the base, multiplying those numbers as well as squaring those numbers will also be very, very easy. How is that possible here? Okay, we have a method what is called as Yavadunam Tavaduni Krutya Vargacha Yojayet. You need not have to remember so many things. Very, very simple. How much ever it is excess or deficient. First, there are two cases are there. The first case is excess I will take. You take, I want to find out the square of 12, that is 12 squared I want to find out. Is it nearer to the base? Yes, it is near to base. I am going to take it as 10. Suppose I want to find out the square of 104. I want to find out 104 squared. So is it nearer to base 10? No, it is nearer to base what we have got, which is called as 100. So we have identified that the number is nearer to base. Okay. Is it greater than the? Yes. So therefore, whenever it is greater than the base, we think of excess. Whenever it is less than the base, we call it as deficit. We are going to. So in mathematical terms, we are going to have some delta x, which is plus or minus delta x related to base we are going to have. So hence, in case of my 12 squared, Yavad Unam means it is less, but from in mathematical thinking, it is a deviation you take. If it is excess, add it. If it is less, you subtract it. Since 12 is 2 greater than 10, so what I will do, since it is greater, I'll add the 2, then write the square of the deviation, that is 2 squared I am going to write. So 12 plus 2 is 14. So, and 2 squared is 4, I am going to get it. So if it is greater, 12 is 2 greater than the base. So hence you are going to add it. If it is excess, add it. Remember, this is the first case I am discussing. Write the square of the deviation. I am going to get 144. Similarly, let me take up. I want to find out 13 squared. We already know it is 169. Let me check this method here. So 13 is 3 greater than 10. So whenever it is greater than the base, add it and write the square of the deviation. So I'll get, so 13 plus 3 is 16, 3 squared is 9, and get it here. Clearly, I'll go ahead so that we can try to solve the problems. Suppose I am ending with, I am going to get, let us say I want to do 16 squared. I know you may be knowing some of this squares later. So 16 is greater than the base, that is plus 6. Okay. And write the square of this here. It is 6 squared and write. 16 is equal to 22. I'm going to get, this is 22. Okay. But here there is a problem here. 36. If I simply write 36, 2236 I am going to get. Since the number is 16 and it is nearer to the base 10, how many number of zeros are there in this? Only so many digits can stay here. I know in the unit place, and whatever the 10th place is there, you shift to the next position. Now 22 plus 3, it is equal to 25. So answer becomes equal to 256. We are going to get it like this. This you need to remember. Since it is nearer to base 10, the number of zeros here is 1. So hence only one digit can stay in the squares of numbers. The remaining part you can shift it here, 256 like this. Okay. Similarly, let us go ahead. I want to find out the square of 104. 104 is nearer to base 100. So it is greater than 100 because I am talking the first case I am taking here. So therefore, it is nearer to base 100. How many zeros are there? There are 2 zeros are available. So therefore, so I can have 2 digits here. Even the deviations also I'll write in terms of 2 digits. Since it is greater than the base, I'll add that much. I'll represent the deviation also in 2 digits. 104 plus 04. I'm going to get it here. Very nice, man. 10816. And I'll write the square of this one here, which is 04 square. I'm going to get it here. 04 square. I'm going to get it here. So I can write 104 plus 04 is 108, and 4 squared is 16, and it is possible since the base is equal to 100, so 2 zeros are there, 2 digits can stay here, so 4 squared is 16, answer is 10816. Similarly, 107 squared, you can type the answer here, 107 squared. Now you have observed it is 7 greater than 100, so add that much, so I'll get 107 plus 7 is 114, 7 squared is 49. Very nice, answer is 11449. I'm going to get it here. Very nice. Similarly, let us go ahead. Can you try to solve, so what is the square of 108 squared? You try out. You can directly look in and you can write the square of that. 108 squared I want to try. Yes, 100 plus 8 is 116, not and 8 squared is 64, answer is 11664. Excellent. So whenever it is greater than the base, we have to solve. Now let me try out. Can you try this 1003 squared? You try out this. If you have understood the problem properly. So 1003 squared is, you need to find out on what is the base we have got. It is nearer to the base 1000. So always express the deviation also in terms of this. Yeah. So therefore, very nice. So what I will do, see, therefore I have got 1003 is there, and again, please don't jump into the conclusion directly. Kindly focus on what is the base here. I will express the deviation also in terms of 3 digits, that is 003. This is very, very important. 1003 plus 003, yes, 003, and 003 squared I'll write. 003 squared is 009. So hence I am going to get the answer as 10609. Excellent. Nice. We have dealt with the numbers which are greater than the base. Now let us check with the numbers which are less than the base here. Now let me try out. So it is 98 squared I want to find out. 98 is nearer to the base 100, but in my case it is less than the base. Yavadunam tavaduni krutya, how much if it is lesser, you subtract that much. But keep in mind, that's the deviation also in terms of what is called as 2 digits. So therefore what I will do, 98 is near base 100. So 98 is 2 less than 100. That much. If it is less, yes, subtract that much. Then write the square of this deviation, that is 02 squared. Hence I am going to get 98 minus 02, I'll get 96, and 02 squared is 04. Excellent. Your answers are coming. Very nice. Similarly, let us try out, since you are getting it, can you try out some of these questions here? You try out 97 squared, okay, and try 96, 92 squared, 94 squared, and all such things. 94 squared, 99 squared, 998 squared, like this. Okay, so nice. So 93 less than 100. So 97 minus 3, which is equal to 94. 3 is 09, therefore 940. Nice, you are getting nice, good answers. 4 is 6 less than 100. So subtract that much. 94 minus 6. I'm going to get 88. 6. Subtract that much. That is, yeah, for this 94. I'll write 94. So that 88. And it is 6. Therefore, I'm going to get 36. I'm going to get 99 squared is very, very simple. 99 minus 1, it is equal to 98. And yeah, very nice. Kushi, you have given 980. Now, 998 sorry, 998 squared. Now, please observe, in case of 998 squared, so I am taking this 998. 998 is nearer to the base 1000. Please be careful. Deviation is 002. This is very, very important. Since it is less, subtract that much. Therefore, I'll get 996. Very, very important. And square of this is 004. Don't directly jump to the conclusion. Please have patience in solving the problem. Now, hope you have understood these things here. Very nice. I think so. We have dealt with what is called as, that is, squares of numbers ending with 5 and the squares of this one. And one more thing also. So I want to find out, yeah, whenever it is square of number ending with 5, you have told square of numbers which are nearer to the base also you have told. What about in between numbers? Suppose I want to find out, there is what is called as a method, what is called as duplex method is available. What is called as duplex method? What we do, very simple. Whenever you come across a single digit, that is d of a, I'm going to get it here. That is duplex of a. Don't think it is a derivative because in differential equations and all these we see d, it is derivative of this. In our Vedic maths, d is duplex of this. Whenever a single digit you get, you write the square of that, that is a square. But whenever you get 2 digits, you write 2ab, that is a and b, that is a and b. We take it as 2ab. I'm going to take it here. Simply remember this. This is more than sufficient to solve a square of any number. If they are not nearer to the base or whenever it is not a square of that one, we have a duplex method also. I'll discuss only a single problem, a simple thing, so that we can try to solve the problem. I know very well that 12 squared is 144. 12 squared is 144. Now I'll use duplex method. I'll start from this side. I'll observe single digit. Whenever you get a single digit, what we do, single digit means a is 2 squared is, I'm going to get it as 4. I'll do. Next, I'll get 2 terms, that is 1 and 2. Whenever you get ab, write 2ab, 2 into 1 into 1, 2 into 1 into, sorry, 2 into 1 into 2, 2ab. So that is 4 I'm going to get. Once you reach the last term, last number, then 1 you delete. That is, I have got 1. So 1 squared is 140. Yeah, you told it's simple. Let us take up something like this. 23 squared I want to find out. So what I do, either I am going to start from here. So like this is 3. Single digit 3 squared, I'm going to get it as 9. Then move ahead. I'll get AB. So whenever you get AB, 2 into A into B. 2 into 3. 2 into 3. That is equal to 2 2s are 4, 4 are 12, 2 and 1 carry. I have reached the last digit. So remove 1 by 1. So therefore I'll get only 2. Single digit means square it. 2 squared is 4. So add these two. I'll get the answer is 529. This is applicable to any number also. That means you can easily solve the problem here. I don't want to increase the complexity. That's why I'm going to take up only one 3-digit number and I'll try to solve, so that I don't want to, like, suppose it goes like this. You can use a method also. 112 is near 12 greater than 112 plus 12. It is equal to 124, and 12 squared is 144. 125, 4 also you can write. Or let us try to solve by this method. I'll start from here. I'll get a single digit. Squared is 4. Okay. Then move ahead. I'll get 2 digits here. 2 into A into B. 2 2s are 4, 4 1s are 4. I'll get 4. So when you come across 3 digits, so club the first and the last, and the middle one is separate. Middle one is separate. There is 1 squared is 1. First and the last, AB. 2 into A into B. That is 2 into 2 into 1, 4. 4 plus 1 is 5. Hope you. Okay. Don't be in a hurry to solve. Since we have reached the last digit, leave 1 by 1. That means I am going to leave out this 2. So we left with 1, 1. A into B. 2 into 1 into 1. That is 2. This also. So 1 squared is 1. You'll get this 125. Or even if you solve by deviation, that is 112, 12 greater 100, 112 plus 12, and get 112. This one is 124. 124. So 12 squared is 144. Since it is base is near 100, only 2 digits can stay. So therefore 144 is 44, and another one carry it comes here, which is added here. Your answer becomes 12544. So this is a duplex method where you can solve square of numbers and any square of numbers. So we have dealt with squares of numbers. Now 1 or 2 other patterns. Hope it is okay. Okay, it's going on well. 1 or 2 examples we'll take it up. Now let us check this. So whenever you want to multiply, 9 is having a very, very important thing. When I want to multiply, I know very well that 8 9s are 72. I know. So here, eka nyunena purvena we have to do. That is 1 less than what we do. Here also single digit, here also single digit. It is to whenever you are going to multiply with, whenever you multiply with, subtract 8 minus 1 is 7, 9 minus 7 is, and it is 2. It is very, very important whenever you are going to multiply with the series of 9s. Let us want to find out 6 into 9. Eka nyunena purvena we are going to use, that is 1 less. I know this is single digit and also this is single digit. So take the other part of this one here. 6 minus 1 is equal to 5. 9 minus 4, answer is equal to 4. Good. Let us go ahead so that we can try other problems here. So let me increase the complexity. I want to multiply, let us say 24 into 99. Okay, 99. Again, number of digits on the both the sides. Here also 2 digits and here also 2 digits. And these 2 digits are 99. So eka nyunena, subtract 1 from this. 24 minus 1 is equal to 23. Then then 9 minus 2. 9 minus 2 is 7. 9 minus 3 is equal to 6. We can go ahead like this. There are so many methods are there. These are all usually available in any of these multiplications. And one more thing, this is what is called as the 10th place, the unit place 10 and the 10th place are same. So the answer will be ekadikena, that is 3 4s, the answer is 12 and 6 4s are 24. I can get it like this. Similarly, for this type of problem, I am going to have, so here 10th place is same, and when you take the sum of the unit places 10, so therefore 4 into next number, 4 5s are 20 and 8 2s are 16 you are going to get. So these are very, very simple multiplications. You can definitely look into the thing and we can go. Similarly, so many other methods are also available. You know, x plus a into x plus b, there is a method we have got x squared plus x into a plus b plus ab. Whenever you solve the problems of this type, so we know x squared plus x plus ab x into a plus b plus ab. We do here plus ab. This you can separate it out, ab. This you can separate out. You can see this can be expressed as 13 is 10 plus 3. So my x is 10 and a is 3 and 12 is. Now the multiplication is very simple. What I do, you focus on this AB, that is the deviation, product of these two. 3 2s are, I am going to get 6. Then x plus a plus b, x plus a, 10 plus 3 plus 2, or I'm going to get this is equal to 15, I'm going to get. So you can get lot many such problems which are arithmetic in nature here. So this is some basic things related to what is available in the arithmetic thinking here. Okay. So we have looked into the polynomials and also this one here. We have tried out something, a small thing what we have tried out. I'm going to just go ahead. So we have decimal system, hexadecimal and also the binary representation. In hexadecimal representation, so we have, so my A is 1010 which is 10, B up to F we will go like this. So to think of adopting digital system, we should have a correlation between what we are doing in decimal system to what we are doing in the hexadecimal system. If these algorithms are applicable, then definitely we can try to think of applying this in the digital system also. So this we know what is a nibble. 4 bits 1010, it is A hexa. I have omitted representation hex. Okay, please bear with that. Byte and also word. Word differs from NC programming, it differs from one system to another system here. Now let me look into this here. What we have, whatever the first row what I have written, it is related to decimal number system. Whatever the below part is, it is related to hexadecimal system. In the decimal system, 9 is the biggest number here, single digit number here. So we know multiplication of 9. 6 9s are, I'll subtract 1 from this. That is equal to 5. 9 minus 5 is 4. Similarly, 74 into 99, I want to multiply. 74 minus 1 is 73. 9 minus 7 is 2. 9 minus 3 is 6. Is this applicable when you want to do it here? So we need to correlate hexadecimal system. No, F is the highest digit in the hexadecimal. So therefore, 9, the F is also is going to play the role. I want to multiply 4 into X, F, and all these, whatever the below representation are hexadecimal. So when you multiply, so 4 into F is, so I can apply the same algorithm here. So 1 less, that is 4 minus 1 is 3, and F minus 3 I have to do. So F is equal to 15, 15 minus 3, which is equal to 12. So answer becomes equal to 3C. Similarly, I want to multiply 23 into FF. So subtract 1 from this. 23 minus 1 is equal to 22. F minus 2. F is 15. 15 minus 2 is 13. That is D. 2 DD. Yes, it is applicable. Similarly, I want to find out. I know 25 squared. 2 3s are 6. 25 we have just practiced. My 8 in the hexadecimal place, it is not just 18 squared. It is 18 hexa. And all the below representation are hexadecimal representation. So what I will do, again same formula. So when I did 25 squared, the number behind 5 is 2, 2 3s are 625. Similarly, number behind 8 is 1, 1 into 2 is 2, 8 squared is 64 in decimal, and hex. In hexa it is 40, so answer is 240 hexa. I want to add 228 hexa squared. So number behind 8 is 2, 2 3s are 6, 8 squared is 64 in decimal and 40 in hexa, 640 directly I need to get it. 34 into 6, that is, so when you see the unit place sum is 10 and the 10th place numbers are same, so therefore you can see 3 into next number, 3 4s are 12, and simply multiply like this. This is also applicable. Similarly, these are also applicable even in vertically crosswise also. You start from right hand side, 3 1s are 3, then move ahead, 2 into 1, 3 into 2, 3 2s are 6, 6 plus 2 8, 2 2s are 4. This is 483 decimal. If I say E2 and 3 in hexadecimal also, you start from here, 3 2s are 6, then E into 3, 3 into 2 becomes 30 hexa, and E into 3 is 2A. When added, it becomes 2D06. That means we have correlated that whatever arithmetic multiplication, which is algorithms or methods which are applicable in Bharati Krishna Tirthaji's work, it is definitely applicable in hexadecimal system also. Can't we try out this in the digital system? Now this is a line diagram. One of the experimentation is being done in our electronics department by Mr. Arun Kumar, who is doing a research in applications of Vedic mathematics in the digital system. So it goes like this. This is an architecture 2x2 Vedic multiplier. We know this method, the vertically crosswise or UT method or Urda thread BAM. 2x2 Vedic multiplier is there. Then we wanted to have a 64-bit by 64-bit Vedic multiplier. It has been many methods, those who are going to study logic design and also the computer organization, they'll be knowing carry lookup adder, carry select adder, carry save adder, and all these implementation and a comparison of multiplier using different adders tried out here. You observe the last column, which is called as Karasubal method, which is the fastest currently existing methods. We got in the papers, it is mentioned that the product of 64-bit numbers it takes the time of 28.2 nanoseconds to get the answer. But when we tried with Urdhva Triadbha method, that is the carry skip adder, carry lookup adder, and carry select adder, we got 6.576 nanoseconds, 6.968 nanoseconds, and 12.84 nanoseconds, almost less than half of the time which it's going to take. One such implementation is done, and we are trying out with different other methods also. So we worry about trying out all these when we are going to calculate mentally and all such things. Now we are moving to an era of what is called as machine learning and artificial intelligence, and data science is playing a very, very important role, where big data analytics, huge data is there, huge computation is going to take place. We are doing computation. A less reduction in time is a very, very important thing. That means we want to try out reducing the time which is going to take place. If you are able to come out with the new architectures of arithmetic logic unit using Vedic mathematical methods, definitely in the next era of 10 years or 20 years, definitely plays a very, very important role in doing what is the computation of huge data. It is possible here. There is a research work which is going on in the foreign countries related to cheap, low power chips which do only a smaller things here, which is, can we, because our processor, we know whatever, see, we are going to buy a laptop from 25,000 rupees or 1.5 lakhs rupees. But what is the utility perspective from the processor perspective, as well as the power what we are going to utilize? It will be less than 20%. So that means we are not utilizing it, is unless simply it is built keeping in mind many applications we are going to do here. So now the engineers are thinking, in the Illinois University, they are doing in a way such that, can we do only those things which are very, very important for this? That means I want to cut down I want to reduce the power, means I have to reduce the gates which are used in the system, and by you want to reduce the number of gates and also the logic in the system. So that means to say that I want to simplify the logic. I want to simplify the logic means I have to have a good mathematical thinking of that one. Can we try out this with the Vedic mathematical method, so that by recognizing the patterns which are available, can we implement such things in the ICs so that we can reduce the power also, and in turn we can do the green computing also, is a new thinking. If we are able to do such things, last paragraph of this, we can do better multiplier and further performance and reduction in the power, as well as we can do Vedic digital research also, which definitely what people are thinking of true green computing means reduce the power, because we are generating we are generating a lot of heat is generated throughout the world, and we want to reduce the power consumption, as well as we want to maintain the environmental temperature also. Can we try out this, is also another observation. We can definitely do it here. So with this, there are a lot many things are also there. So what are the other things which are available? Just in another minute, I am going to finish this. There is an app is available. You can type Maths app. You can type this in your mobile. You can download this app. You can practice so many problems which are related to arithmetic operations. For whatever we have done in polynomial and all, it is not explained. Only arithmetic operations of so many other problems, it is explained here. There is a web, what is called as math2shine.com is also available, where you can learn, but it's a paid channel is there. We can subscribe for some of them. I am not marketing it, only for the benefit of those who want to learn. Definitely you can go through this, and also you can learn. All these methods are also explained, and also in what way you are progressing also it is explained. And so many videos are also available in YouTube. And one thing which is available for addition, language doesn't matter, because only the numbers matter, and also polynomials. Dr. Amela Vahanulu, he has given so many lecture videos also. They are available. You can definitely have a look into that. being a part of Institute of Vedic Mathematics in UK, I have already given the small insights into this, and all the international conferences details are also available in the website www.istavm.org, or you can just Google Vedic Mathematics IAVM. You can have a look into all these things. And this year, if everything goes fine, we will have an international conference on Vedic Mathematics from 28th to 30th. Still another 1.5 months there. Those who come up and learn and come up with the different methods of Vedic mathematics and all such things, and I'll send you the mail related to the conference also, so that any mathematician, student or faculty who are working in your direction, and also you can implement a Vedic mathematical method, and also related to ancient Indian mathematics also, you can present some papers also. With that, end my presentation. Thank you very much. Great interaction also. If any questions are there, have a interaction session. Yes, sir, please.
Thank you, sir.
Yeah.
Rachana, madam.
There are some questions are there. Just I will answer over. There are tricks to remember table also. Let us say you want to remember 21 table. Okay, 2 in the 10th place and 1 is the unit place. So my in the next addition will be 4 and 1. So go on adding in the unit place 1. That is 1 1. Again 1 plus 1 is 2, and 2 plus 1 is 3. You can go on adding. And in the 10th place, go on adding 2. 2 plus 2 is 4, 4 plus 2 is 6, and you can go on like this. Similarly, let us say I want to do the table 19th table, because whenever students or even faculty also, we have learned, or over the years we have practiced up to 15 table. And nowadays, students as well as we ourselves, we are not using our available arithmetic logic unit in our brain. We have to always keep in mind, yes, we have to always practice this. It's a good practice. So numbers like 29 table, 39 table, 99 table, and all these things. You take 19. 19 can be represented as 220 minus 1. So we take 2 minus 1. That means minus 1 is the operator in the unit place. So go on operating this. So 9 minus 1, 8, 8 minus 1, 7. You go on like this. And in the 10th place, 19, that is 1. So my number is 2. 1 plus 2, 3. 3 plus 2 is equal to 5. We can have a good thing like this also. And related to polynomial and all the so many tricks also, you can work out so many problems. Yes, sir. Ramanand, sir.
Yeah, so wonderful, sir. All are complimenting you. Excellent webinar and all those things. We will be posting your email ID also if they have any queries, and they can interact with you later also. So now we are going to post the link for the feedback and to get the certificate. There is one question I will just read out. Can sir, any suggestions for solving differential equation through Vedic mathematics? It is one question.
With that again, because this was an initial interaction. Since we have done with the polynomial factorization and all these things, it is tried out. It is possible because of differential equations, we are going to find out CF and PI, that is a particular integral. So whenever we are going to divide, that is either the denominator will be d square plus 4d plus 4 or d square plus. Again, we can think of it's a polynomial. Again, we are going to take it to the numerator, that is either x plus 1 whole to the power of minus 1 or x minus 1 whole to the power of minus 1 and all these things. And in that cases, the multiplication becomes very, very simple, and you can solve the problem within a, like in one line itself. So kindly, you can write to my email ID, sir, if anybody. I can definitely share that also. Even I'm going to share it with you, some of the examples also, so that whoever the attendees are there, you can definitely share with them also. Yeah, it is.
Okay, sir. Thank you. We have already, sir, we have already posted your email ID so that they can interact with you personally also.
Yeah.
So almost same type of questions are coming.
Yeah, yes, sir. Currently, even for the differentiation also in the book, Vedic mathematics book, which is available, what they have done, they have factorized the given polynomial. Whenever you are going to differentiate a polynomial like x to the power of 5 plus 4x squared plus 3x plus 2, something like that, it is written in a way such that in terms of factors it is written and they have given. So no such much work has been done in terms of differentiation and integration. Only some small examples which are very initial are given. But definitely there is a way to work in this particular direction to simplify the solving methods. It is possible. We mathematicians and students of mathematics have to work in this direction to bring out the Indian mathematical system also so that we can solve the problems easily.
Thank you, sir. I think Rachana madam.
Thank you, sir.
Yeah.
Thank you, sir, for the wonderful session. I think it was very helpful for our students, especially for answering their aptitude test very soon. And there is a lot of messages are coming that the session was very good, sir. And for the note of the participation, the link of the webinar, link for the feedback session is shared in the chat box. Please feel free to fill the feedback form. And about this.
Yeah, I think some feedback is not taking. Somebody has typed. I think somebody can try out now. If the feedback is, if the link is open, yeah. Please go ahead now.
Yeah. If you have any difficulties to fill the feedback form, please revert us back. We'll clarify it. And like some of your queries are like, can we get the recorded session of this webinar? The recorded session of the webinar will be available in our YouTube channel, St. Joseph Engineering College, Vamanchur, Mangalore. You can go there and you can have a look into that. As there are no many queries, shall we bind up the session, sir?
You want any final points to be told from my side, or?
Yeah, you can take 5 more minutes, sir. 5 or 6, 7 minutes. You can take it, sir.
Yeah. So for those attendees who have, it's very nice. You have given a great opportunity for me. I can see around 400 participants have participated. Many faculty members are there as well as students who have discussed. Nowadays, Vedic mathematics is taking a very great boom because to come out from the students, some of them they are facing very much difficulty in the liking towards Vedic mathematics in a way, so that it is some students they start hating mathematics itself. For them to convert into a good mathematical student, definitely we can try to give some simple problems so that they start liking numbers, they start liking polynomials, so that once they come out of that negative thinking of or what is called as a math phobia, definitely we can make those students who are finding it difficult in mathematics using Vedic mathematical method to think in terms of mathematics, and also to start liking the mathematics, and they can definitely do wonders in the coming days also. One thing. Second thing is not necessarily we have done any research in any particular direction. You can definitely go through these books also. Don't directly try to master in one day itself. It may be a lengthy procedure. So whatever we have discussed for today, have a look into that and try to practice. Don't try to adopt this directly to our children unless we are thorough with this. At least the students from the age of 12 onwards, you can try out once you have thorough and also you have practiced that. So don't unnecessarily directly try with your children and make them and force them to learn this. This is one suggestion I can give it to parents and also or any teachers who are there. As well as we can try out these methods, and so only available book is Vedic mathematics, which is available, and most of the work which has been done is based on this itself. But we can definitely try out different ways of solving the problems by looking into the Sanskrit shlokas, and all the other things are also it is possible. And those who are working in history of mathematics or anything into Indian history of mathematics and Vedic mathematics, as well as applications of whatever the research you are doing, and having a small flavor of Vedic mathematics also. The international conference is open for you all, where it's very simple. Only we need to register, and also the registration amount only we have to pay, and all the paper presenters will be definitely given a free of cost available. That is the while presenting. So 2 days stay there, as well as the food will be definitely given. This is just to motivate those who are working in ancient Indian mathematics also. That's a great thing which is taken by IAVM in this direction also. And please download the app if you are interested, as well as look into the books, as well as try to propagate. Only you become thorough with that, then only you can try to teach somebody and work out different problems also. Then you can be thorough with that. And we are trying to implement this in the digital system, and also we are going to work on a project of implementing this Vedic math arithmetic logic unit. We want to build completely based on pattern recognition, which is available in Vedic mathematical methods. And can we try out in a span of some 2-3 years an IC which is completely based on Vedic mathematics also? We are trying out this. An initial start we have made in the electronics department, mathematics as well as information science department of RV College of Engineering. This I want to tell. And apart from that, there are so many shlokas, and in the 12th century, 8th century to 12th century, Sanskrit scholars have done a wonderful work, even in the related to graph theory applications. Because whenever we think of graph theory, we go for Euler's method, which is started from 1735 onwards. But before that, our Sanskrit scholars, Kalidasa and so many other scholars were there, and poets, they have played with that. Since the lack of time, I was not able to explain that, where the movement of the what is horse in the chessboard also, it is explained in terms of shloka, and so many other things are also available. Definitely we can look into that, and also we can come out with these important things also. Thank you, ma'am. You can please proceed.
Thank you, sir.
Yeah.
As we have come to the end of this webinar, I thank Professor Raghavan Prasad wholeheartedly for accepting our invitation and for sharing his knowledge. Indeed, this was a wonderful session, sir. I'm sure all the participants have definitely benefited from this. Thank you, sir.
Thank you, ma'am.
I sincerely thank the management of SJEC for giving us this opportunity to organize this webinar. I thank our HOD, Dr. Ramananda, for organizing this webinar. My sincere thanks to entire Maths Department, Media and Press Cell of SJEC for rendering helping hand in organizing this event. Last but most importantly, I thank all the attendees for the active participation and patient listening. Thank you. Thank you all. Participants, kindly note, feedback form link is available in the chat box. Kindly fill the form. And the certificates you'll be receiving the certificate within a week. So shall we wind up then, sir?
Thank you. I think we can wind up now.
Okay, sir. Thank you all. Stay safe, stay healthy. Have a great day.
Anand sir, it's really a great thing, and a great opportunity for me to express myself also. Yes, sir, I was very happy to.
Thank you, sir.